Hi, my name is Varun Dhawan. I'm a principal PM with Azure Database for Postgres team at Microsoft. Today, I'm going to talk about the massive shift which is happening in the data architecture pattern and the rise of Postgres as the everything database. So please join me. So let's dive into the talk. Rise of Postgres as the everything database. So with the explosive data growth, thanks to the social, mobile, AI revolution, most of the data systems are now segregated into being an OLTP system or an OLAP system. OLTP systems are optimized for writes, while OLAP systems, are optimized for scans and aggregations and reportings. This leads to a continuous data movement challenge via ETL or some sort of an ELT pipeline, which introduces the latency and failure point, and that's the real stack complexity problem. So Lex looks into how the data systems evolved into becoming so painful. So when you think about moving data from OLTP to OLAP systems and every all the systems that you have in between, we always end up paying something I call refer as data movement tax. So we pay the data movement tax every time we move the data from OLTP database to OLAP warehouse to Redis cache to Elastic cluster to vector store, and you ended up building more fragile data pipelines. Every pipeline introduces the eventual consistency concern because, believe it, none of these pipelines are always in sync always. And in addition, we also pay a serialization and deserialization cost where data is transformed multiple times across these systems. So imagine transforming JSON back to the relational table, and then so on and so forth. Debugging of these pipelines become harder because failures happens across distributed system boundaries and not in one single place. So what does this tax actually mean for a developer in their day-to-day work? Well, a lot of time actually goes into identifying the real source of the truth, whether it's OLTP, whether it's OLAP, whether it's cache. Joining data across multiple fragile pipelines often require denormalization and pre-aggregation, and testing becomes difficult because the environments don't replicate multi-state consistency. All this means is that your time or your development time isn't actually spent on building the features. The actual business cost of this is staggering. Looking at some of the reports from the Redis and Stripe, 74% of the org use multiple databases, which is more than one database. And as a result, 50% of the developer time, I repeat 50%, which is pretty much half of the developer time, is wasted in maintaining the pipelines and not really building the new features. This also leads to the number one frustration that developers have today, which is the complex tech stack. Cost isn't just in the infrastructure, it's also the engineering time which is spent in maintaining and debugging and troubleshooting these pipelines. I believe that this visual which you see with some of these stats over here is relatable and something that you may have felt at some point of time. Now, how does the data stack, became this complex? Now, in past, every time we had a new data requirement or a new data type, the default notion was let's add a specialized database. Today, however, the unified database instinct is winning. So instead of jumping right into the new tools, newer architecture, the the data architects are pushing back and finally asking how much of this can Postgres handle at the first place. Now, to really understand this operational pain of a highly specialized data stack, I want you to imagine a fun situation. Like think about a busy kitchen restaurant. In this kitchen, think about every specialized database like a special refrigerator for some of your ingredients. So, on a busy day during peak traffic, what happens? You see a chef running across these different refrigerators, which are having these different ingredients. So, somebody runs to Redis to get something from cache, somebody sprints to Elasticsearch to do a search output, and dig into MongoDB to get some documents. Because of this fragmented kitchen model, almost all of the chef's time is wasted or spent into running across these refrigerator and getting ingredients together on the table rather than actually cooking the dish. In our world, this is exactly what developer feels when they spend entire time navigating across the pipelines and moving the data and finding, the real source of truth actually instead of building the feature. There is an overall delay in serving the dish, leading to an unsatisfied customer leaving a restaurant. When we use multiple systems, we pay this massive data movement tax, our products and our customers that suffer for it. That's the real cost and complexity of having a complex technical stack. Now, again, historically, each data system was specialized into one specific data task or data access pattern. So if you're thinking about search, you would always thinking about inverted index, to power those searches. Think about analytics. You're always talking about the columnar uh, storage, so to get, those massive reporting results faster. Cache, which is like just get the fast data. You were thinking about the in-memory key value. Now, partially this was also because there was no one single data store or a database, which was sophisticated enough or scalable or extensible enough to service all these needs. And because of that, we've almost accepted the reality of having these highly fragmented system almost as a cost of doing business. But now, thanks to Postgres, the things are changing. The unified data instinct is becoming more strong. Because of that, Postgres can now support multiple data access patterns thanks to its extensible framework, pluggable index types, and support for custom data types. The developer community is trusting Postgres, and this is not just that I am saying. This is also very evident, in the votes uh, from the developer community. So let's look at the survey results. We were looking at the 2025 Stack Overflow developer survey results. Over 55% of developers confirm using Postgres as their primary database. So, like whenever they have an application requirement, the first database they reach out to is Postgres. With over 58% confirming admiring Postgres, which is like they are actually using Postgres for more than one or two data requirements. So they might be using it for documents, for using a full text search, for using vectors. And then officially, Postgres is right now the number one database in the world. Yeah, no surprise. So what is driving, these pattern changes and these developer, liking, for Postgres? Well, I think it all boils down to one simple questions that developers are now asking. What can I stop synchronizing? When can I stop running around in the kitchen? And when can I actually start cooking? Postgres answers this perfectly. And it has a secret weapon, to answer all these. And that secret weapon is extensibility. Postgres is being decade old, but there was one key fundamental principle, that Postgres was built upon, and that fundamental principle was extensibility. Postgres wasn't built for being a rigid single purpose tool. It was always designed ground up to adopt new data type, new index pattern, new functions, new data access pattern. So technically, it's not just really a database, it's an entire data platform. Now, I've been talking about, how the extensible nature of Postgres can help you, with these handling these different data access patterns, which were traditionally handled by specialized databases. Let's get into some examples. So in the next few slides, let me show you some practical ways how devs can stop uh, synchronizing, across pipelines right now. Let's start with the documents. Now, say you have an application which, along with the relational data, which is data stored in the table, you also need access to some sort of a unstructured and semi-structured document. Think about JSON. You might think, as you think about JSON, the first instinct is that you want to take a detour from your relational database and you want to set up a whole separate data system, something like a NoSQL database in Mongo or Cassandra. Postgres gives you the flexibility of having a flexible schema support out of the box with JSON and JSON-B data types, making storing of your unstructured and semi-structured documents incredibly fast and totally queryable. JSON-B is actually a binary storage, so paired with the GIN index, which is generally inverted index, it enables the fast containment and path queries to your JSON documents. Let's look at the search. Now you can get the full text search access exactly where your source data or your table data already lives. Full text search or FTS, which is also a native feature in Postgres, uses the TX vector for tokenization and TS query for search condition and GIN indexes for fast lookup. Right? Remember, TS vector is a complete new data type which is highly optimized for full text search. This means that you can skip having a complete separate dedicated system for running your searches, something like Solar or Elastic, and you can simply use Postgres for your searches. What about caching? Now, I can't even remember last when I look at a complex application data stack without having a complex caching layer or a Redis thrown in front of the database. Well, if you are using Postgres, you can actually also use Postgres for your caching requirements. You can use the unlock tables in Postgres. Unlock tables can skip the val logging and reduce the overhead of the write complexity. Uh, they are good for ephemeral data, which is like where durability isn't a requirement. So your cache is being stored in an unlocked table, just in case your database gets restarted or failover, your table data gets lost. But again, it's cache data, you can rehydrate it from the main table. So you can take this and combine this with materialized views and partial indexes for advanced caching pattern. So you get cache data performance without the extra infrastructure of hosting a complete in-memory database, meaning you can completely avoid adding a Redis synchronization layer entirely. Okay. And then what about the background task? Now imagine, that if you're using all these database, how often have you come up with a requirement that, okay, well, you've written a select query or you tagged it inside a stored procedure. Now the only thing you need to do is to run the stored procedure at a schedule like a 1 a.m. every day and spit out a report. Like traditionally, if you were always using some sort of a third plugin or a third pipeline, to run these schedulers, maybe in Unix or a Linux environment, you would be using cron. Now if you're in Postgres ecosystem, you don't even need to leave your database to run your background task as a cron job. pg cron extension comes built right inside the database that avoids your external data schedulers. So again, no need to configure something separately. Using a pgcon extension allows you to keep the schedule logic very close to your actual table data and reducing the latency. And then you can always use the pgcon extension to schedule the batch jobs, cleanup, and aggregation pipelines. What if you have a time series data? Like think about constant stream of logs, events or matrix, which is always the timestamp data. Like one example is the weather app or some sort of a Wall Street app for tracking your scripts or stocks. Now always you will think about I need a specialized time series database like Influx, M3 or something like that. If you are in Postgres, there are many sophisticated extensions, and one of those extensions is Timescale DB. Now, Timescale DB provides you with hypertables for partitioning. It provides automatic chunking based upon time, and it is hyper optimized for append heavy workloads, which is like from your IoT sensors, from your DevOps workload, you can ingest huge amount of time series data into Postgres database without compromising the asset books. And this is my favorite. If you're working on the spatial data types or location data, then PostGIS is absolutely best in class. PostGIS adds spatial data capabilities like geometry, geography types. It uses a specialized index, again, a different index, which is R3 indexes by a gist for running these spatial queries faster. It support the advanced spatial functions like distance calculation, intersections, geofencing. So again, this is just not a small plugin to run basic calculation between latitude and longitude. It's a very uh, depth spatial system which can do advanced spatial things. So you can almost use PostGIS plus running on top of your Postgres database and build something sophisticated like an Uber rideshare app, or a DoorDash. Postgres transform your Postgres into a robust spatial database. Now it's 2026. Let's talk about the elephant in the room, artificial intelligence or AI. When building AI apps, your vectors actually belong right next to your relational data. Why? Because your vector actually represent the dimensions which are derived from your data, which is stored inside your tables already. The pg vector extension, which by the way has been there in Postgres for many years, enables the semantic searches directly within your database, right on top of the actual data. So by keeping your vector embeddings at home, close to your source data, you skip the replication cost and consistency issues, in replicating the data between your relational database and your time or your vector store database. And then when you hit the massive scale requirements with your vector data, a U database for Postgres flexible server provides you with disk advanced vector indexes like disk KNN, which dramatically increases the performance of your vector workloads beyond the vector indexes which are provided by default, such as HNSW and IBF. So I've been talking a lot about using Postgres as an everything database for almost every kind of requirement. This is where I want to take a quick pause and also remind that I'm not really saying never use a specialized database. Instead, what I'm trying to say is start with Postgres first and specialize only when needed. Like for semantic search application, the Postgres first approach works best when your data and vectors belong together in the same table. You need a real-time operational insight very fast, and more importantly, you want fewer system to manage. There are chances that you may need a specialized vector database when you require the first-class hybrid search or a massive unstructured filtering. L- You can use something like Azure AI search, for your storing your vectors. So very special requirement. What about graph? It's been very popular data type recently. Well, again, you are in luck. If you are using Postgres, you can actually do graph on top of your data without leaving Postgres. You can simply use Apache Age extension, which brings the Cipher query capabilities and SQL together for full graph experience within on top of your Postgres database. We can run graph queries, calculate the nodes and the weights, and do all the sophisticated calculations. And then finally, if you have an OLTP system, you will always, or most of the time, also need to have an OLAP system to complement, all your reporting and your query requirements. Traditionally, as I mentioned in some of the initial slides earlier, that there is the data movement task of moving the data from OLTP system to OLAP system. Well, now with Postgres, you can actually run the analytics right inside your OLTP system without moving any data. So using the new PGWDB extension, you can run the OLAP analytics right inside the Postgres. So no separate ETL pipeline, no data duplication, and zero latency. Now, if you go through if you revise through a bunch of these slides, what I've explained so far is how you can take a single Postgres and have these different data type, different indexes, different extension and different capabilities all within one single Postgres instance. Well, technically it sounds amazing, but what if you're hitting the resource bottlenecks or resource ceiling, of that Postgres database? It's like, okay, well, I can only do so much within a single Postgres instance running on a specific hardware. The question that I'm asking is what happens when you outgrow a single node limitation in Postgres? In that particular case, you can finally use something like Citus extension, which turns your Postgres actually into a distributed database. Think like a horizontally sharded database. Using a Citus extension, you can actually shard your data across multiple nodes and parallelize queries. So if you see in the illustration how using a Citus extension, you can have a Citus coordinator node and multiple worker nodes around. They all work as one single cluster to your application. What's even better, if you're actually using Azure Database for Postgres Flexible Server, you can use Citus as a managed service with Elastic Cluster. That, by the way, was a very good segue into Azure Database for Postgres Flexible Server. So far we've been talking about making Postgres as this everything database, and the reality is that you want to do all this without drowning into the maintenance of managing this massive scale system. And for that exact purpose, we built the Azure Database for Postgres Flexible Server. So with Azure Database for Postgres Flexible Server, we do the operational heavy lifting for you. We give you the fully 100% open source community Postgres with managed reliability, high availability, read replica for disasters, enterprise grade security, integrated seamlessly in support for Microsoft Intra ID. Now, speaking of security, Azure Database for Postgres Flexible Server meets the most stringent enterprise security requirements with support for encrypted connection, private endpoints, advanced inscriptions, TLS and TDE. TLS is your transport level encryption for your wire, security, and TDE is your transparent data encryption, which is encryption for your database at the rest. And finally, support of intra ID, wherein it allows you to use the same intra ID experience that you use for authenticating the user for your organization to also use the same experience for authenticated users right within the database. But again, with Azure Database for Postgres Flexible Server, we just don't provide the basic hosting service. We go above and beyond and add Azure magic to it. In this particular case, some features. And while there are many different Azure magical features available on Azure Postgres Flexible Server, I'm going to pick up three of them. First one is that we offer the Azure AI extension, which allows you to connect directly to your Azure OpenAI endpoint and run AI functions straight from your SQL queries. So you don't need to write complex C or Python or C++ kind of functions, to query data from your vectors and run your semantic searches. Second, we give you seamless integration with intra-ID authentication, so no more storing username and passwords within the database, which can be compromised at some point of time. You can actually just simply use the Microsoft intra-ID and also get benefit from a two-factor authentication. And then finally, integration with Azure AI Foundry, which lets you run the AI agents securely within your database with the strict user bounded scope. So over here, your agents actually behave as like a real human. So they have a login, they have a scope, and they can only work and reason within that particular scope. So now let's see how this data unification, which I've talked so far, help a real customer in a real scenario. So Apollo Hospital, which is one of the largest healthcare provider in India with over 74 hospital, 10,000 beds, they were blocked by their legacy data backend. Their architecture was heavily fragmented across multiple systems. Transactional system was running into legacy Oracle, analytics into separate data warehouse, a separate caching, and a separate search system. This highly fragmented approach was incredibly hard to maintain for Apollo's team, difficult to scale, and completely lacked the agility required for the future vision that Apollo team had, to better their healthcare experience. To fix this and build the healthcare system of the future, Apollo team went into a 6 months of evaluation phase. And they decided to consolidate their architecture into Postgres as a single unified data platform. Now, what was the number one reason of the choice of choosing Postgres above any other database? It was extensibility. By treating Postgres as a unified data platform, they could handle their JSON and JSONB application data, full text, and even PG vector AI workload all in one single place in one single database. This eliminated the need for data duplication and simplified their architecture, giving them the real-time consistent insight necessary to focus on most important thing, which is provide the best-in-class patient care instead of maintaining and fixing the broken, fragile telemetry pipeline and paying the data movement tax. By running a unified mission-critical database at Apollo's massive scale. Yeah, now this is the point. You we decided the Postgres, but running that massive scale, at massive system at Apollo scale, Apollo required a rock solid infrastructure foundation. For this, Apollo team closely studied the platform as a service option, benefit, and enterprise grade security provided by Azure Database for Postgres Flexible Server. So by moving to Flexible Server, the Apollo's team instantly gained built-in resilience, automated continuous backups and high availability, and the ability to scale compute on demand. This drastically lowered their operational overhead. More importantly, it allowed Apollo's engineering team to stop worrying about infrastructure maintenance of synchronizing across the fragile data pipelines and take that focus entirely on the core business function, which is providing the better healthcare to their patients. Now, Apollo's success story isn't alone. There are many examples which are available, on our customer success stories. So I'll encourage you to check those out. But this example perfectly illustrates the core architecture philosophies that customers are now adopting. That is making Postgres as the operational center of gravity. It's a hub where your business truth, your AI embeddings, your real-time analytics, your search results all live together seamlessly. Now, as I wrap up my talks, I leave you with this thought for future of your data architecture consolidation. Consolidate by default and specialize deliberately. Or if I say in simple terms, start with Postgres for your everything data, specialize only when it's necessary, and let Azure handle the operational heavy lifting of your database. Thank you so much for your time today. Uh, Again, my name is Varun Dhawan, and I'm always happy to connect offline, talk, or answer any questions. So please scan the QR code. And I've also had my LinkedIn profile link over there. So hit me up on the LinkedIn. I'll also be hanging out in the Discord channel right after this talk. So please come, drop a hi or say hello. And finally, enjoy the rest of your conference. Thank you so much.